Continuing with antiderivatives, let's say that we want to find the antiderivative of the function 1 over the cubed root of x. So if we think about a very, very similar function, again, I'm going to do this in a different color. So I'm going to think about the function x to the 2/3 power. If I were to find the derivative of that, this is really the same thing as the cubed root of x squared. So again, remember how we can turn these from radical signs to exponents and keeping certain things the same. Okay, so I'm going to operate off of the top function x to the 2/3 power, and if we were to find that derivative by using the chain rule, 2/3 minus 1, that's going to give me a negative number. So this is going to equal 2/3 x to the negative 1/3, which would be like, if I take it to the denominator, because we want to get rid of our negative exponents, I would have 2 over 3x to the 1/3 power, which would be like 2 over 3 to the cubed root of x, which again is very similar. So again, these are similar to what I'm looking for. So all I'd have to do to get this as my antiderivative would be to cancel out that 2/3, which we can do by multiplying by 3 over 2. So the answer to my question, my original question of how do I get 1 over the cubed root of x? Well, I could take the function 3 over 2, and I'm still going to keep x squared and y cubed, or cubed here. So again, how do we know this? How can we double check our work? All right, well, let's find the derivative of this. So if I go back and try to find the derivative of, oops, that's too big. Let's see here. Oh, I lost one. This is a 3. So let's say that we want to find the derivative of 3 over x squared to the 3rd power, and then it's a 2 down below. I'm going to keep my constant out front. I'm going to, again, use my power rule. So 2/3 minus 1, it's going to go down below. So I'm going to be left with 2 over 3, the 3rd power of x here. And then when we simplify this, again, my 2/3 and my thirds are going to cancel out. I'm just left with to the 3rd power. So again, always double check your answer. I thought this was my function. Okay, I was able to plug it in and then find the derivative of this function, and I proved, hey, that was actually what we were looking for. They match, so we did it correctly. Here are some examples of different derivatives and antiderivatives, or again, finding the integral. So again, keep this handy, always reference this. Again, common ones, e to the x, natural log of x. This is, number to the power of x, and then our trig functions, sine, cosine, tangent. So again, it's good to see them. I think it's nice to see them back to back. So if you're finding the derivative of sine x, you know it's cosine x. If you want to find the antiderivative of sine x, it's going to equal negative cosine x plus c. Notice all the antiderivatives do have plus c on them, which I guess we should have added over here. All right, so if we take a look at another example, again, referencing my cheat sheet here, okay, a number to the power of x, that's like this example right here. So again, if I look at, all right, I want to find 3 to the negative x. Well, I know that 3 to the x would be 3 to the x ln 3. So 3 to the negative x is going to equal negative 3 to the negative x times natural log of, and this is actually going to be 3. So again, this was like, think of this as like side work. This was like side work looking at up here. 1 negative, so f of x, my antiderivative equals, again, how could I get this right here? This is what I'm looking at. How could I get this? I would say that I have and then when you go ahead and simplify that, it equals negative 3 to the negative x all over natural log of 3 plus c. Again, we can always check our work. So if I think this is the answer, I'm going to say, all right, well, let's find the derivative of this. So I'm going to say, find the derivative of this function. And so I'm basically going to use my quotient rule, low times derivative of the high. And I'm going to just drop that c out because it doesn't need to be in there. Minus high times derivative of the low. That's a 3. And when I go through again, I'm going to get a lot of canceling out. I'm going to get a lot of things on the top and on the bottom. So I'm going to end up with negative times a negative, positive, ln 3, ln 3. I'm going to be left with 3 to the negative x, which was exactly what I was looking for. We've also got this thing called initial value problems. So if I look at the function, so dy dx equals x squared minus 1, and I know that at y of 3 it equals 7. The general antiderivative, so first I'm going to try to determine what's the antiderivative of x squared minus 1. Well, again, basically what I do is I take this, I move it up front, but I move it as a fraction. So I'm going to add 1 instead of subtracting it. So I'm basically thinking, all right, 1/3 x to the third, and then I think what would make this have a derivative of negative 1? Well, it would just be minus 1x, and then again, plus c. I always have plus c. So my general antiderivative is going to be this equation right here. Now I'm going to take the second part of my function and plug those numbers in. So I'm going to say, all right, every time I see an x, I'm going to plug in a 3. So I'm going to say 1/3, 3 to the third power minus 1 times 3 plus c equals 7. This is really 27 over 3 minus 3 plus c equals 7. 9 minus 3 plus c equals 7. 6 plus c equals 7. Therefore, my constant is equal to 1. So the equation, again, what was my initial value? How did I come up with this equation? I had to go find the constant, and it was x to the third over 3 minus x plus 1, because I now have my constant. Do one more example like that, another initial value problem. So we're going to say, all right, the derivative of this function equals 2x minus 1 over x squared. X cannot equal 0. And then y of 1 equals 5. So I'm going to say, all right, let's find the general antiderivative of this function. So my antiderivative, again, this has an exponent of 1. So I'm going to increase it and then divide it by 2. So really it's like saying 2x squared over 2. And then again, I'm going to rewrite this as x to the negative 2. So I'm going to bring that down, and then so this would be like saying, okay, negative 2x, negative 2 minus 1, negative 3. Then looking at the second part, I'm going to say, all right, I know that if I took 1 over x and found the derivative, that would give me negative 1 over x squared. So I can apply that and say, all right, if that's what I'm looking for, then I know that the antiderivative of this highlighted yellow section is going to be 1 over x plus c. So again, simplify this. It's basically x squared plus 1 over x plus c. And now we have our values. Every time I see an x, I'm going to write a 1. And every time I get to the equal sign, it's going to equal 5. 1 plus 1 plus c is 5. 2 plus c is 5. Therefore, c equals 3. So I take my derivative. I take this equation right here, and I rewrite it with my constant plus 3.